In the last video, you learned about how a position time graph is represented, and then I told something known as velocity. The slope of it gives us the velocity, right? Now there are two important concepts, speed and velocity. You guys already know what is speed and what is velocity. Speed is basically what? It is the distance traveled by time taken, correct? Now, the speed, what we say, it's a scalar quantity. Okay, be very careful. Speed is a scalar quantity because distance and time both are scalar quantities. Okay, but whereas velocity is given by, it is actually displacement by time taken. Okay, so velocity becomes a vector, it has a direction. Alright, so speed and velocity, you guys already know the difference between them, right? Now, but there are different types of speeds actually speaking. Okay, so one is what we call as uniform speed. Okay, uniform speed is where it covers equal distance in equal intervals of time. Okay, so as you can see in this is basically uniform speed. Then comes variable speed. That is, if it covers equal distances in unequal intervals of time. Okay, like this. Alright, the third is what we call as, average speed we call it. Okay, average speed is basically the total distance the body covers by total time taken. Okay, total distance by total time. Right? See, in this case, car is moving from A to B, then B to C. Right? Now, total distance is A to C, and then total time taken is the time taken from A to B plus time taken from B to C. Okay, this is basically what we call as average speed. Okay, there is one more thing, what we call as instantaneous speed. Okay, this instantaneous speed is very important because instantaneous speed, it tells us that at that particular instant, what is the speed? Okay, at that particular instant. So what we refer to this instantaneous speed as, we call it as delta S by delta T. Now, delta represents a very small change. Okay, that is in a very small period of time, maybe like 1 second. 1 second, what is the change in the speed? What is the change in the speed we try to calculate? Okay, so in 1 second, how much of distance did I cover? We calculate that. Okay, so that's why we call it as delta S. Delta S is, in 1 second, how much you can travel? Very small distance, correct? So that small distance is delta S, and that small time is delta T. So we take delta S by delta T, and we take the limit of it, delta T tending to 0. Don't worry about limits, you are going to learn limits. Okay, so we say limit as delta T tends to 0, delta S by delta T. This is basically what we call as instantaneous speed. See, in your car, when you're going that speedometer, it actually gives you the instantaneous speed, meaning at that instant, what speed you're in. It can be 60, it can be 80, it can be anything. Okay, those are all instantaneous speeds. Okay, so these are different types of speeds what we have. Alright, then comes velocity. Same thing is there in velocity also. Okay, velocity, you guys already know, displacement by time. Then comes uniform velocity. Uniform velocity is if it covers equal displacement in equal intervals of time. Then comes variable velocity. Same thing, equal displacement in unequal intervals of time. Okay, then comes your average velocity. Same thing, average velocity is similar to average speed, so the total displacement by total time taken. Okay, then comes instantaneous velocity. Same thing as instantaneous speed. Okay, where for a very small amount of time you will do very small displacement, correct? So that is basically what we call it as instantaneous velocity. Okay, now the important point is to differentiate between this in the problem. Okay, so in the later on videos you will learn how to differentiate between them.